So now we got the characteristic equation. We find the roots of it. How our constants relate to omega n and zeta. And remembering okay, I'm going to go back to here. Go back one slide. There we go. Oops, go back 2 slides. For the voltage equation, then the way it would work would be that A1, oops, where's my drawing tool? Oh, I'll go back to here. There we go. A1, little a, get my drawing tools out, there we go. Little a 1 is going to equal 1 over RC. Yeah, 1 over RC. A2 is going to equal 1 over LC. Moving on. Go to this equation. A1, in this case, A2 in both cases is going to be 1 over LC. A1 in this case is going to be R over L. Okay. Remember that. Write that down somewhere. Keep it handy. Keep it handy reference as we go back and forth between all these equations. Okay. So let's go escape again. And let's go, let's see, what slide were we on? I think particularly we were on this slide. We were talking about this. We get down to the equations, the relationship between omega and omegas and the A's. Now, example, what do we do in this case? Well, we've got to divide everything through by, oops, what did I do there? I forgot to put my pen on. There we go. Get all my stuff back. Divide everything through by 4, the leading term at 4. So we're going to get 1 times the second derivative, 2 times the first derivative, and 4 times the constant term. That would make omega sub n equals 2 equals the square root of this one, square root of this. Omega sub n equals 2, not omega sub 2 equals 2. There we go. There we go. Omega sub n equals 2. The zeta is going to equal the A1, which is 2, divided by 2 times by omega sub n. Yeah, 2 times omega sub n, which is 4, or half. 0.5. There we go. Every time I do a little, the way this writing on a PowerPoint slide works, every time I do a little circle, it thinks I'm trying to do something else instead of making a dot. Yeah, crazy machines. Okay, let's see. Erase all. Let's just erase it all for now. Let's just go see what the book says it's going to be. Same. Yeah, take a look. What they're showing you. How the characteristic equation connects up with the differential equation. Okay. Omega sub n equals 2. The zeta equals half. Okay. So we get this normalized form equation, and now we can get a solution to it. And actually, this should look real familiar to you guys. Remember I said you're finding the roots of you're finding the roots, and it's going to be dx dt minus root 1, which is at one of these s's. Except in this case, I should probably say plus. Instead of using r for root, be more conventional with their symbols. Plus S1 x equals 0. Dx dt plus S2x, the second root, equals 0. Well, this is your first order equations. Take a look right there. This is exactly the solution of the first order equation. What we just finished. This connects first order with second order. Second order just ain't that hard. That's my message. That's my message here. Lots of symbols, lots of little squiggles, new omega n's and zetas and a1s and a2s and s's and all that stuff. It's just algebra. This looks so much like your first order equations, which we just finished, which you guys know how to do. Okay. Moving on. Then we get, and they go on and prove it. They do the substitution. I showed you my way, which should be convincing, I hope. And then you get, well, the solutions to the quadratic equation right there. It's just solving the quadratic equation using these coefficients. That's all it is. High school algebra.